Hey everyone, welcome to Solving Day 3. In our last video, we talked about solving polynomials. Remember, we wanted everything equal to 0, and we usually factor, so we can set factors equal to 0. Then we looked at radical equations, and that introduced must check number 2, squaring, not square root, squaring both sides. If you see squaring both sides, that's a must check. Okay. What else? We also talked about rational exponent problems. Where we raised both sides to the reciprocal power. So if I had x plus 2 to the 2/3 equals 4, then I would raise both sides to the 3/2 power. Remember, we also said here that when we raise both sides to a power with an even denominator, don't forget the plus and minus. Okay? Don't forget that plus and minus. So if I raise both sides to the 3/2 power, I have an even denominator. That means I'm going to need a plus and minus here. So let's finish that problem. Right now we're talking about x plus 2 to the 2/3 equals 4. And then I'm saying, hey, let's raise both sides to the reciprocal power. Ooh, I see a denominator equal that's even, so I know I have a plus and minus. And the way I evaluate this is I say square root of 4, that's 2. 2 to the third, that's 8. So I get x equals -2 plus and minus 8, which is -10 or +6. Those are my two solutions, okay? So don't forget that plus and minus when your denominator is even. Okay. What else? Well, then we talked about absolute value equations, didn't we? And we said in the last video, that absolute value equals x stuff is must check number 3. So must check number 1, x stuff in denominator. Must check number 2, oops, squaring both sides. Must check number 3, there it is, absolute value equals x stuff. These are my must checks so far. And I'm also going to add, it's not a must check, but it's a don't forget. When you take the even root of both sides, don't forget the plus and minus. Okay, so I'd like to do a couple more of these absolute value problems. How about x squared plus 6x equals 3x plus 18? All right, I'll do this one as a warm-up, but then you're going to do the next one. So I write the positive component, and I'm going to move it over a little bit so I have some more space. I'm going to write the negative component, x squared plus 6x equals -3x minus 18. Notice I'm changing all the signs. I'm not just making the conjugate here. Okay, so move everything onto one side because this is x squared. It's 3x minus 18 equals 0. This is going to be x plus 6, x minus 3. Sure glad I practiced all that factoring before having to do the solving. So I get x equals negative 6 and x equals positive 3. Here, I'm going to move this stuff over, and I'm going to have x squared plus 9x plus 18. And that's going to factor as x plus 6, x plus 3 equals 0. Get x equals negative 3 and negative 6. So again, I have 1, 2, 3 solutions. Do you think there are 3 solutions? Well, let's think about this problem graphically. This is a linear equation with a positive slope and a positive y-intercept. This is a parabola inside an absolute value. Now, if it wasn't inside, it would have x-intercepts at 0 and at negative 6. Okay? And my parabola would look like this. But what does this absolute value do? Well, it takes all this stuff down here and it flips it up because it can't be negative anymore. So my parabola looks like that. How many points of intersection do you see? I see 3. I think they're all going to work. All right, well, let's try. If I plug in a negative 6, negative 6 times negative 6 is 36. Negative 6 times 6 is negative 36. So I add those together, I get 0. Negative 6 times 3 is negative 18 plus 18 is 0. So that works. How about 3? 9 plus 15, 24. Absolute value of 24 is 24. 3 times 3 is 9. 9 plus 18. 9 plus 18 is not 24. It's 27, you rube. All right, and so I get 27 equals 27, so that's good. And if I try a negative 3, negative 3 times negative 3 is positive 9. Negative 3 times 6 is negative 18. So that's negative 9 inside the absolute value, which is 9. Over here, negative 3 times 3 is negative 9 plus 18 is also positive 9. So all 3 of those answers work. Sometimes they all work, sometimes one of them works, sometimes none of them work. You won't know unless you must check. So please make sure you must check. All right, so here's one for you. 5x minus 1 plus 7 equals 3x. Okay, pause the video, try this one, come back when you're stuck, we're done. Hey, welcome back. So you can't write the positive and negative components until you isolate the absolute value. So I can't at this point write positive and negative components. I've got to move this over here. 5x minus 1 equals 3x minus 7. Now, when I've isolated the absolute value, now I can write the positive and negative components. So my positive component, 5x minus 1 equals 3x minus 7. And my negative component, 5x minus 1 equals negative 3x plus 7. All right, let's see what happens. I get 2x equals negative 6, or x equals negative 3. And over here, I get 8x equals 8, or x equals 1. All right, should we have 2 solutions? Well, you know, the way I'm thinking about it is, this original equation, and don't get me wrong, absolute value equals x stuff. This is a must check. But think about this graphically. This is a linear equation with a steep slope. This is the absolute value graph shifted 1, squished by a factor of 5. So that's where the vertex is. Oh, except that it's moved up 7. So I'm actually way up here. And I look like that. So I don't know that this, and maybe those will intersect, but I think I only get one solution here. So let's try out both of these in the original equation. Not in this equation, in the original equation. Okay? So let's plug in a 1. 1 times 5 is 5. 5 minus 1 is 4. Absolute value of 4 is 4. 4 plus 7 is 11. 1 times 3 is 3. That doesn't work. And if I plug in a negative 3, okay, negative 3 times 5 is negative 15. Minus 1 is negative 16. The absolute value of negative 16 is 16. 16 plus 7, 23. Negative 3 times 3 is negative 9. Oh, I was right. They don't actually touch each other up there. Whoa. No solution. Okay, so gotta must check. Gotta must check. And thinking about these things graphically can help. How about this one? Absolute 3x plus 2 equals 4x plus 5. Give that one a try. All right, welcome back. 3x plus 2 equals 4x plus 5, and 3x plus 2 equals negative 4x minus 5. Here, I'm going to move this over and move that there, so I'll have negative 3 equals x. And here, I'm going to move this over, and I'm going to move that over, and I'm going to x equals negative 1. Okay, two solutions. Absolute value equals x stuff tells me that these are must checks, so let's get about must checking them. Negative 9 plus 2 is negative 7. Absolute value of negative 7 is 7. Negative 3 times 4. Negative 3 times 4 is negative 12 plus 5 is negative 7. Nope. And so what if I plug in a negative 1? Negative 1 times 3 is negative 1. Negative 1 plus 2 is negative 1. Whoa. Wait, start again. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1. Negative 1 plus times 4 is negative 4 plus 5 is positive 1. I get one solution. Okay, so one solution. And I'm thinking about this graphically. I've got negative 2/3. And I've got this linear equation with a positive slope, which I think goes something like that. This slope is bigger than that slope, so this one has to be steeper than that one. All right, only one solution. All right, so don't forget absolute value equals x stuff is a must check. All right, the last thing I want to talk about is actually something that we've already talked about, and that's solving rational equations. And remember, with rational equations, that brings up must check number 1, where we, if we have x stuff in the denominator. If ever we have x stuff in a denominator, that's must check number 1. Okay. So let's see about these problems. Okay. How about 4 over x minus 5 over 3 equals x over 6? Well, rational equations are these fractiony ones, and we said what we should do is multiply by the least common denominator. In this case, the least common denominator is 6x. Because 3 goes into it, 2 goes into it, 3 goes into it, 6 goes into it, and x goes into it. So when I multiply everywhere by 6x, here the x's cancel, and I'm left with 24. Here I can take out a 3, so I'll have 2x times 5, which is minus 10x. And here the 6's cancel, and I'm left with x squared. Because this is an x squared, I'm going to move everything onto one side so that this is equal to 0. And I'm going to have x squared plus 10x minus 24. Okay, does that factor? Sure it does. X minus 12, plus 12x minus 2. You know, the people who do 6 and 4 try and do this, and that works to get that, but that doesn't make this when you multiply them together, because positive times positive is positive, not negative. So these are mine. X equals negative 12, x equals positive 2. So why is this a must check? It's a must check because I have x stuff in the denominator. And really, all I'm looking for with this must check is that one of my answers doesn't turn this into 0. You know, you can plug negative 12 in and see that the stuff over here equals the stuff over here. You can plug in 2 here and 2 here and see that the stuff here equals the stuff here. But really, that's ought check. The must check part of this is I'm checking to make sure that my answers don't turn this denominator into 0. These answers don't turn that into 0, so I'm fine with this. I'm going to move on. But when I come to a problem like this one, 1 over x minus 6 plus x over x minus 2 equals 4 over x squared. 4 over x squared minus 8x plus 12. Okay, remember, we need to use the least common denominator. It's not going to be this times this times this. Notice this factors as x minus 6, x minus 2. That's the common denominator. See, there's an x minus 2. See, there's an x minus 6. So I'm going to multiply each of these terms by the least common denominator. X minus 6, x minus 2, x minus 6, x minus 2, x minus 6, x minus 2. I know you don't want to write it all out, but my experience is definitely I make fewer mistakes when I do. So now I have 1 times x minus 2 plus x times x minus 6 equals this cancels this, and this cancels this, so I just have 4. So that's great, no more fractions. Now I'm ready to solve this quadratic as soon as I distribute and combine like terms. And since it is a quadratic, I'm going to move this 4 over. Don't forget to combine like terms. X squared minus 5x minus 6 equals 0. X minus 6, x plus 1. So what do you get? 6 and negative 1. Remember, though, this is a must check. I've got x stuff in the denominator. Do any of these answers turn these denominators into 0? Well, yeah, actually. This one. 6 minus 6 is 0. Sorry. Negative 1. Nope, negative 1 is fine there, because then I'd have negative 3 in the denominator. Yep, negative 1 is fine there. I'd have negative 7 in the denominator. And this is just made up of those two things. So negative 1 is my only answer here. Okay, x equals negative 1 is my only answer. Remember, when you have algebra stuff in the denominator, that's a must-check situation. All right, how about this one? 1 over x plus 3 plus 2 over x equals negative 3 over x squared plus 3x. All right, why don't you try solving this one? Come back when you're done, and we'll see how it went for you. Welcome back. So did you realize that this was x times x plus 3? And look, there's the x plus 3, so this is my least common denominator. I'm going to multiply everywhere by x times x plus 3. Don't forget to cancel. 1 times x is x, plus 2 times x plus 3 equals these, cancel those, negative 3. So when I distribute, I get 3x plus 6 equals negative 3. 3x equals negative 9. X equals negative 3. Is that my only answer? No. No, it's not, is it? Because what happens when I plug a negative 3 in there? Negative 3 plus 3 is 0. I can't have 0 in a denominator. It's also true if I plug negative 3 in here, I'll get a 0. I just need 0 in the denominator in one place to know that this is no solution. The only solution we were able to come up with doesn't actually work. So this is no solution. All right. So we've covered lots of different solving types. Yeah. And so now you've got this worksheet for homework with assignment 22. And that assignment 22 homework worksheet is brilliant at giving you practice with each of these different types. I would definitely do that assignment, and I would definitely check my answers in the solutions channel to that worksheet. Make sure you're doing them right. Don't just do the problems and then not check them. Because if you're doing the problems wrong, then you're going to get them wrong on the test. And you're only going to know you're doing them wrong if you check the answers. So please check your answers. Do the work first, but then check your answers. I've got the answers to all the things in our Office 365. And there's, when you go to our Office 365 team, you'll see the channel for solutions. That's where you'll find them. Go. Do the homework first, then go. Don't have the solutions open while you're doing the homework, because then you're not actually learning anything. All right, take care, everyone.